Yes, it's my great pleasure to introduce our distinguished guest. To be honest, I didn't have time to go in detail to your CV and expertise. So I will use this opportunity to ask you kindly before you start to introduce yourself shortly and then go to your topic, which will be very interesting to all of us in our research group and Tamara in general. So please, I will not waste your valuable time, just will give you floor and ask you, as I said, to introduce shortly yourself, the field of your expertise, and to go on with your today's presentation. Thank you very much.
Thank you. Yep. So excuse me. So I am Timo Kiravuo, as you know, and my background is that in the 90s I was working for a Finnish company called NIS2. Maybe somebody has heard. It kind of became over time a leading security company. In the beginning it was not a security company, and then from NIS2 I drifted back into Helsinki University of Technology to teach digital communications and security, and when that turned into Aalto University, and I decided to get a doctorate and got my doctorate in cybersecurity. And after that I found that there were no free teaching jobs at the moment, and a friend asked me to go consulting, so I went back into the field, and I learned very fast that in theory there's no difference between theory and practice, and in practice there's quite a lot of difference between theory and practice. It's like my first customer was a big government operation, and they had systems starting from late 90s. And how do you secure a system from late 90s? You really can't. You just put it behind firewalls and more firewalls and WAFs, and that's it. So I have kind of academic experience and practical experience and doctorate, and I am a generalist. So I am not a specialist in anything, but I see that as a benefit because, especially with the customers, it means that I can take different viewpoints. And I'm also teaching at Aalto and Metropolia. Metropolia is a local University of Applied Sciences or college in Helsinki area. And I enjoy teaching and my own voice quite a lot. Yeah, and I'm not quite sure how long I have my Aalto contract continuing, because I have had only temporary contracts at Aalto for 5 decades, on 5 different decades already. But you can reach me at the IKIFI address, that will work always. So today's topic, I did a survey for the Cybersecurity Center of Finland 2 years ago on state of software industry, security and software industry. That has some insights and viewpoints. When I have noticed that right now people are not aware of EU regulation, and the EU regulation that is coming and has already come, that will actually impact the software industry and security in general in Europe. And when I have some viewpoints on maritime security, but I'm no way a maritime expert. I have had brushings with maritime industry every now and then. I know a tiny bit, but mostly I know enough that I know what I'm ignorant. But I think that I'll be able to provide some viewpoints. And if you want to ask any questions, please raise your hand on the Teams app, and when I can kind of, I'm used to teaching, so I can pick your questions, and I think that I have now set it so that I can also see the chat, so you can ask on the chat also. Yeah. Okay, let's go forward. So this survey, the key findings, things are all over the place. Some companies have their security very tight on software. So these were companies that were producing software, and we did interviews and workshops, and others, to say politely, were not so advanced. And basically it was not quite like in the 90s, but where they say that we have a firewall, we are safe, but it was very close to that. And especially a very typical thing is that you add the security, try to add the security afterwards, and that just doesn't work. Also, we don't have enough good practices, we don't quite know how to do this right, and there's a shortage of skilled people. So even companies that want to do security, think that it is important, they don't have staffing to do it. They don't know how to provide support for people. And when there's a key issue, customers don't really ask for cybersecurity. And that is a big thing that I'm not going into too deeply, but one problem is that customers are not demanding security. Our problem is that we don't know how to define security. Even if you do, I have been doing government requests for projects or products, and we still don't know how to define cybersecurity. So in practice, if you go to a field and ask that, okay, are you asking for cybersecurity? They say yes. Okay, what are you asking for? Well, we ask, are you secure? And if they say they are, we accept it. If they have ISO 27000, that's good enough for us. And anybody who knows ISO 27000 knows that it's not bad, but it doesn't really prove very much. Even if you have certification, there are ways to get around the certification process. Yeah, and this report is available, unfortunately, in Finnish, but you can find it and do Google Translate if you want to get into the details. But I'll summarize here. So, I have been going to consulting in companies, and in some physical manufacturing companies, I walk in and they have these yellow vests and safety helmets, and I ask, are you an IT company? And they say, nope, you can see we are not an IT company. We dig holes and we manufacture something. And when I ask, do you have a ERP, the Enterprise Resource Planning software? Yes. And if that says, boom, how long can you work without an ERP? 2 days. So all companies are now IT companies. And that is something that companies are now starting to see, but are not yet seeing. The same thing as on the maritime sector, all ships are IT systems. You can't have a system without digital components anymore, and especially on new ships, if you have archiports and so on, it's all digital. And this understanding is not yet through the industry. Some companies get this, lots of companies don't yet see it. In one case, I was talking to a harbor management company, and they said that they use IT for billing, they have yellow vests, and they have flashlights. But even harbors are changing now. And when there is a question of what we call existential risk, that can a company go under? In a shipping, there was of course a Maersk, and Maersk had a big incident, and they didn't disappear, but they got hurt very much. In Finland, we had a company called Vastaamo. It was providing psychotherapy services, and they actually went under. And the managing director is now in court, or was in court. I think that he has been sentenced already. So we are in a situation that IT is actually critical, and this has not yet been realized. Some companies do, like we have Uber, Airbnb, like we have a taxi company without taxis, or hotel company without hotels. Those companies realize that they actually totally dependent on IT, and they will actually lose customers like Uber. If Uber goes down, customers don't wait in rain, they switch to Bolt. But still many companies don't get this. And that is kind of one finding. And then also in software business, even companies that make software don't think about security, especially those who are making bespoke software for small amount of customers. They just think that, okay, we make this and we ship it out, it's good enough, no problem. And when in a survey we ask management, is cybersecurity important? Yes, of course, cybersecurity is very important. 72% of people said that it is very important. These are not statistically significant. We don't do a Gallup survey, so this was open questionnaire. But 72% said that it's important. When we ask people to list, put in order of importance, and turns out turnover is more important, cash flow, having happy people working for you, those are important, and cybersecurity also. And that's the reality. I mean, there's nothing wrong with that. We have to understand that if you have a company, if you are not making money, that is an existential problem. Companies go into bankruptcy because they don't make money. Very few companies go into bankruptcy because of cybersecurity. So we have to live with this. But our thing is that on paper, companies say that yes, we should have cybersecurity. But when you ask that, okay, how do you require it? Well, we have it mentioned in our strategy. How do you monitor it? We don't really monitor it. We just say that there should be cybersecurity. So there is room for improvement. And when we ask programmers, coders, how to improve security. Now, one problem is staffing. And here, several companies said that they don't have enough security people. They know that they don't have enough security people. So they are trying to spread their skills and knowledge around. And one method is cyber coach. So those people that you have who know security and software, they go around to software teams and helper teams. Like when you want to do the walkthrough, when you invite a cyber coach and he goes through your code, he checks what are your interfaces actually sanitized properly and helps. So you don't have a security person in a team, but there is a person who comes to the team. Just checking, did somebody, so I can see the chat now.
We don't have questions so far. I will let you know if somebody would like to ask. Don't worry.
If there's a question, tell me, because I can see the chat and I'm afraid the team should do something funny.
No problem. We will manage it. Thank you.
Okay, yeah. So you don't have dedicated people for each team. You have one person going around. Our thing companies are doing is that we are finding the people because lots of the people are interested in security. I don't know why. I have been doing security and I think security is boring. And actually I want to keep security boring because when security is not boring, it's bad. So as boring as we can is good for me. But they find people who are interested in security in the coding team, and when those people are they might get some training, but basically they are told that, okay, you are a cyber champion, so you are looking at security, and when you think that there is something that you need help at, when you contact us. So you have a security team that is available, and when you embed certain coders in the coding teams, so that keep your eyes open and ask for help, and that way you have a skills flowing. And one thing about security is that security it's an art. It's not a hard thing that, okay, here is 2 kilograms of security. It's a skill and you have to grow it and develop it and learn it. So that way they are enhancing the skills in the teams. Then other thing is that how a company organizes its software processes, and here different companies do differently, but typically quite now we are having independent software teams, fairly independent, but how independent it differs. And in some companies, very IT driven, the software teams are actually business units. So the software team and business unit are the same thing, and the software team has the product owner and the business owner in the team working together. That is fairly rare. Typically, you have a product owner who then talks to the business people. And I'll talk about the authority a little bit later. But then our thing is that this leadership interest in security is now growing, but it is still not yet very far. But EU regulation will mean that in the future, the management will be more interested in security. And when there are process developments, something called shift left. Shift left means that when you have your process chart, you have a beginning in the left, and people are trying to push for security to a beginning and not add it afterwards. Okay, I'll get into that in the next slide. I once again was tweaking my slides at the last moment. But first, the organization. And here we have been hearing from security people that actually there are no cyber risks, there are no security risks, there are only business risks. And what I have seen in my career as consultant is that very often the security people and the business people are not talking to each other and especially not understanding each other. And if a security person says that we have a cybersecurity risk, it means nothing to a business person. It's not their field. But if they can put it as a business risk, that we have a risk of losing this and this much money for some reason, it makes sense. And that is something that is not yet happening, but there is, I'm involved in guiding one doctoral thesis where the topic is management awareness of security and how to present security management in such a way that management can understand it. So here's a research question, like how to make cyber risks become business risks. We are not very far. We are still using the 5x5 matrix. It's like if I go to an insurance company and ask what how many car accidents will happen next year in Finland, they can tell me close enough. But on cybersecurity, how big is your cybersecurity risk? Biggish, not so big, half big. We can't do that yet. And when it comes to who is responsible for security, and here typically, traditionally, in a regular company, people are saying that IT department is responsible for anything IT, and cyber risks belong to IT department or security people in IT department. And that makes no sense because they are business risks. And if you have a business, you cannot move that business risk to somebody else. You cannot transfer responsibility. You can transfer actions and work, but not responsibility. And that means that whomever says yes or no a project is responsible. You can't have it any other way. And this one is not being realized yet, that whomever makes the decision to go ahead is taking the risks also. And I think that in the next 10 years, we are going to be seeing it happening because of EU regulation, that management is starting to understand that cyber risks are business risks, but they need to be educated. And we don't have tools for evaluating the risks yet. We have partial tools, but not enough. Yeah. And in one company, they told that, yep, they have it so that the business units are responsible for cybersecurity. And then one thing that is that the cybersecurity team is a department of yes. You ask for anything and they will say, yes, let's see how to do it. They don't say no. And that is another mindset thing. I have been lecturing about this quite a lot, that as a security person, my task is to be enabler. It's not to say no. And we see a lot of this, like especially with GDPR and privacy, we see your GDPR person is saying, no, you can't do this. That's useless. The task is often to figure out how to do it. So my task is to figure out how to do something in a secure way. And here once again, the management should learn that, okay, we can't have people who just say no. We need to have people who can figure out how to do whatever they want to do. Sometimes you have to say no. I mean, the no is in my toolbox, but it's not the first tool. Yep. So current problem is that the responsibility for security is undefined. Everybody assumes somebody has it, which nobody has it. And if something happens, you just get the blame game. And that needs to change in our industry. And when we get to a software process, and what is at shift left, and we have lots of tools, we just need to get them to use. And one thing is that you should start with threat analysis and analyze the concept. I have been involved in a project where they said that, okay, the architecture is ready, and now we can do a threat analysis. No, you are too late. You should have done that before you did the architecture in the beginning. Like, we have this idea, can we do it? How do we do it? Then we have secure coding guidelines, we have different requirements. We can set the requirements as needed. And when we can do a testing and so on. So all of these practices exist. And there are manuals and instructions. There's a NIST framework, what is the American one. OWASP has lots of good instructions. That is the open web application software security project. And for operational technologies, we have this IEC 62443 and especially section 4.1 on how to make secure software. Oh, sorry, my printer is making noise. I have not soundproofed my office well enough. Yeah. So anyway, there are ways to bring security into the software process. You just have to do it. But main thing is that you start the security in the beginning, not at the end. You can't add security afterwards. People try all the time, but we are too late. And we asked about that, and we found out that 6% of responders said that they do it in a concept phase when you should start to do it. 17% at a specification phase, which is still good. 22% at the start of implementation, which is a bit late. And 11% do at the end of implementation, which means that you have built something and now you start to think, but is this secure? And that doesn't make very much sense. You build something and then you ask, what can we deploy this? So that means at the end, okay, do we throw away what we have just spent a year building, or do we deploy it knowing that it is not secure? And people do this constantly. I have actually killed one product. It was about 200,000 euros of development, but just, sorry, I was a consultant for a customer, and as a consultant, of course, I cannot kill a project. I can just bring it up, and that is my duty. I'm serving a customer, I'm taking their money, so my duty is to go and tell them that, hello, you have developed this product, and now I think that somebody above the team should think that, do you really want to take this business risk of this product? And they decided that they don't want to take a business risk. And if they had done that in the beginning, they could have figured out that, okay, we have all of these issues. We can have to figure out how to solve all these issues before we start even design. Yeah. And then 28% of responders said that they don't do any threat modeling. They just build software and they think it's okay. They might do secure coding, but they don't really think that what is threatening, what might happen. And that is a little bit scary. So threat modeling, we have different tools. And for example, when you have done the architecture, there's Microsoft Stride and other tools. But what I like is to start in the concept phase, in the idea phase. And here, it's very simple. You have three cases, three use cases. You have a happy case. We make a software that does this. That is about 10% of the code. When you have unhappy cases, that means that something goes wrong. And that is a typical system, like you have all of these things that, okay, we need to get a new password, we need to get a new device, something goes wrong, whatever. And if you look at the typical like government software, 10% does what government wants to do, 90% does what the government must make sure that should not happen or should happen in a very controlled way. But then what people still forget is the evil case. There is actually somebody who gets in and starts to play around with your software, breaks it, reverse engineers it. Anytime you make an app on a mobile phone, that app can be reverse engineered. We have these obfuscation tools and so on, they just slow down the reverse engineering. You send out JavaScript that can be reverse engineered. And I have seen web services where the authentication is done in a JavaScript in a web page. And that just means that anybody can get there. And usually the JavaScript is like too messy to figure out easily. I remember in the old days before JavaScript, I remember editing web pages, like you have these little forms and you just take the code, see, okay, here we have these hidden fields. I can change this hidden field easily, reload the web page, my web page that I edited, and say, and I get in, no problem. And people don't think about the evil cases, and people don't do this in the beginning at the idea phase when they should be doing this. And if you just go through these three simple use cases, happy, unhappy, evil, you get a lot done in the beginning before you have any code, before you have any specification. You just need to understand that whatever you are doing is going to be targeted, somebody's going to be attacking it. Okay, any questions so far? Feel free to ask. I tend to like my podium here. Now, next thing is that we are in European Union, and the European Union loves to make regulation, and they are here to help us. And here is most of cybersecurity regulation. NIS2 came into effect last year or this year in Finland. Basically, it says that management is responsible, and otherwise it's like ISO 27000 lightweight version. It's not very demanding. It does not affect all companies. It affects communication sector and bigger companies that do manufacturing. Then one that people don't know about is the Cyber Resilience Act. And the CRA will be very important to software industries and anybody who is selling anything that has a digital component, like washing machines. Our current washing machines fall under CRA. And basic clause is that you have a life cycle responsibility for repairing your product. So if there are any software vulnerabilities in your product, you have to issue updates. You have also reveal what your software product has eaten with SBOM, software bill of materials. It's like the label you have on food packages. What is it? What are the ingredients? What frameworks, what libraries you have used? And my estimate right now is that this CRA is going to be big for software industry, and any industry that has software in its products, which is most industries. there is not very much you are anymore making without some piece of digital item inside it. Like ships, like the navigation equipment in ships, like the engines in ships, like cars, like whatever. There is also update to the radio equipment directive, which means that anything that has a radio, which once again is almost everything, has to be secure. And when there are our directives, the critical entities is for the society's critical actors. The DORA is for finance sector. It has been in power a couple of years, and DORA has impacted finance sector very much. And when they have, the NISA is getting authority to create standards for European Union. And that means that in the future, these regulations are now coming, and because of them, EU will still define regulations and interpretation further. So the regulation tsunami is coming. And main point of a cybersecurity regulation now is that the management is responsible. That is in NIS2. And that means that now we are starting to see the management are asking about security. And then basically you have to do risk analysis, you have to be forward oriented, you have to have security by design and security by default. So you can't say that the customer did not turn on the security, it's customer's fault. No, you have to have a security. And you can't say that, oh, well, it's software, it's not designed to be secure. You have to, if you are selling software, new software, you have to be able to show that yes, we designed it to be reasonably secure. The reasonably is a very big field, so, but at least you have to show that you have thought about it a little bit. Then there's registration, and some software products will require the CE registration. That is the Certified European, the same as electrical devices. If you take any electrical device, it has the CE, which means that they have done self-evaluation and sent documents to something called notified body. Now, some software, not all, but some software will require self-evaluation and notification. So software industry will be regulated, which is a new thing. Yep. And then at Aalto, we did a survey of what we can find over Finnish internet looking for OT system, operational technology, the cyber physical devices, and we could not get in. So we can see that, okay, here is an OT system. The law allows us to get as far as see it, but we can't touch it. Now the government is getting the right to investigate. So now the government can actually get into the systems and investigate. So things are changing. European Union has also data regulations, the GDPR we everybody know. There's Digital Markets Act to, well, in practice to put Google and Facebook into their place. And Digital Services and Data Governance Act and Data Act, those are interesting because they are saying that you have to reveal how you are using our people's data. Data should be reusable. That is not trivial, but on the maritime sector, there was actually an project on the TOOP, the once only principle, where you enter your data to one government entity only, and it will be passed on to the rest of European governments. I don't know how it ended, I just saw part of it. But basically the idea is that you enter your data once and it can be reused in a safe and secure way. And then Data Act. If you send data someplace, you can retrieve it back. And if you have looked at the SaaS services, software as a service, of course, all of SaaS services work very hard to make it very, very easy to enter your data and make it very, very difficult to get out of a service so that they can get a customer login. And now EU is saying that no, you can't have a customer login. Your customers have to have a way to get out of your system also. And the AI Act has been debated, and the AI is, of course, AI will change things, but let's not go into that one. There's too much happening and not happening there. But the EU is saying now that you own your own data, you can control how it's used, you have access to get your data back, and also making sure that the large players, the usual American big companies, don't get too much dominance. So up to now, on the internet, on software, on computers, we have been free to do pretty much what we want. And now, starting from a GDPR, this is changing. This is going to be a regulated field. And at Aalto, I have been pestering people about, okay, what are we teaching about software regulations? And people are saying, what? Software legislation? What? So right now, people are not realizing this change yet. So if you want to teach something, that will be something to teach. Not everybody has to be a lawyer, but just realize that if you are making software, you have to be responsible from now on. And with NIS2, I have been doing this with companies. Basically, the management is now asking, do we have cybersecurity? Management doesn't yet know what cybersecurity is. Not really. Management is taking some training, and they are writing a paper that they have a training, so that in case somebody comes and asks, they have been trained, but they don't. It's like it doesn't happen immediately, but it is happening. And NIS2, you can actually get by just by doing some paperwork and saying that you have evaluated your risk and you have not found any risks. And then if something happens, you say that, okay, we are stupid, but we tried. NIS2 has also these big fines. So if you really blow it up, there are big fines for a company. But one kicker is that NIS2 doesn't put penalties into a management, but the owners can sue a management. Because if a management doesn't do cybersecurity, it will harm the owners, and when the owners can come back to a management and say that there is a law that says that you have to do cybersecurity and you didn't. Other issue is a supply chain requirement, which means that you have to also ensure that your supply chain, especially software, but also subcontractors, are secure. And that means that if you have a two-person company, they are not covered by NIS2, but their customers most likely are, which means that in practice, NIS2 will impact everybody more or less. So subcontractors, either a main contractor has to provide a security for them, or they have to do something themselves. And when NIS2 basic requirements, the 21st article, they are ISO 27000 light. They are not very requiring. They say that you should do basic things. You should have a management involvement. You should do it risk-based. So you have to think about what are the risks and have a approach based on risks. And then you have to report to a government if you have an incident and so on. So NIS2 is not really a game changer, except that it puts responsibility to a management, and that might be a game changer. And the CRA, I estimate, will be more of a game changer. And it's not yet in effect. It will come to effect next year. But you have to fix those vulnerabilities. You have to monitor your product and provide updates. And it covers quite a lot. All IoT is covered. All the doorbells, little cameras, whatever included. Open source is excluded until you use open source. If you put open source into your product, then you are responsible. So I think that this will impact the software industries quite a lot in next 5 to 10 years. Especially as right now situation is like this. Randall Munro, most I assume know the XKCD. It's a very entertaining comic or cartoon. and he says that all our infrastructure is depending on some random little project that somebody is maintaining, and that is true. There was this one little piece of JavaScript somebody took off the distribution because there was a name dispute and it broke tons of stuff. Some years ago we had this log4j, that is a JavaScript, not JavaScript, but the logging little Java piece that it turns out it was really a little bit too much information from internet. It had a big vulnerability. And first question was that everybody was asking, do we have this? Do we use this? The answer was, we don't know. So it's besides your frameworks. So today when we are programming, we don't start with an empty file. We take a framework. Framework includes hundreds of libraries quite often. So you get a ton of little components from somewhere on the interwebs built by somebody, and you are relying on all of that software, and you are hoping that there's no vulnerabilities in any of that software. And when if there's something in somewhere, you don't even know if you have it. And when there are intentional vulnerabilities, 2 years ago about, or last, I don't remember, I'm at that age that I don't remember years anymore. There was somebody who got into the open SSH project and said that, hi, I could help a little bit, I could maintain this library, I could be kind of made a little fixes, and then was replying to different people and saying, oh yes, we can, was like very competent looking junior developer, but yeah, I like to do this, so that I learn. And then eventually got seniority in a project, became a senior maintainer, and then added little backdoor to OpenSSH. We of course don't know who this person was because it was all online. But you can guess, most likely some countries' intelligence services sent this, will not be surprised. So all of this household cards is being attacked by people who are maintaining this stack of software, and we don't know what we have. And now the CRA and NIS2 don't directly say it, but in practice they imply that you have to start to maintain the dependencies, you have to know your software, and we will be getting these machine-readable SBOMs, software bill of materials, list of ingredients, so that you can actually know what you are having in your own products, but also in products you are buying from somebody else. And that means, and when we have tools, of course, we already have those tools and they will get better. So that means that when you can actually be aware that if a vulnerability is found, you will be notified. Then, of course, after you have been notified, you have to figure out what to do about it. That's the next step, but at least we know that we are vulnerable. And AI will also be used. AI will also be used by criminals, of course. But here is space for making new products and research if you are interested in. And this is like this is not a coding problem, this is a management problem. How do you manage what you are doing? And I have been doing security since the 80s, and my opinion right now is that we have enough technology. I mean, we will be having more technology, but technology is not a problem. Managing the technology is a problem. In security, we are seeing more and more management problems, and how do you handle this big mess you have? How do you know what you have? When we talk about quantum computing, that might break encryption in 5 to 10 years, maybe, we don't know. The thing is that you need to update your encryption software. You don't even know what encryption software you have. If I go to any IT shop and say that, okay, can you provide me a list of what encryption products you are using? They can't do it, not easily. Yeah, Okay, any questions so far about EU regulations? I think that these are pain in the posterior. They will make things harder for us, but it is kind of healthy for us that we go through this and improve our security, whether we like it or not. Now on a maritime, my sister has a sailboat and I have been sailing. That's about what I know. So I'm not pretending to be a specialist on this, but since I'm a besserwisser, I of course have opinions. One thing is that the EU regulation will impact, even if it is maritime systems are kind of international and you can put them on a different flag and so on, the EU regulation will impact the industry. And then, of course, that what I assume everybody knows, that we are both IT and OT, and the thing is that with IT, anytime you have an IT security problem, you can always pull a plug. So on IT, our default response is a deny. It used to be, long time ago, it used to be that you blocked what was recognized, like on a interface, when you sanitize your input. In 90s, people would write that, okay, we don't allow these characters. And we learn very fast that that doesn't work, especially with Unicode. Unicode broke verse filters totally. So now we write code that says that, okay, this is what is allowed, anything else will be blocked. You have your firewall, you say that we allow these things, anything else is blocked. You have your certificates. If a certificate is not up to date, connection will be broken. Problem is that on operational technology, if you break a controlling connection, you are not controlling a process, whatever process is, and you have a problem. So you can't use the same solution on OT side. You can't say that, okay, the bridge certificate to control the propulsion is outdated, so the bridge cannot control propulsion anymore. That's not a good thing in a ship, as far as I understand. I'm not a specialist. Yeah. So that is one big challenge, what I understand. And then, of course, you have the life cycle issues. And I have been looking into the IMO's security because I'm a curious person, and also because when the DNV, Norwegian DNV bought NIS2 a couple of years ago, and I was a little bit involved in the process as a consultant also, and I looked into what DNV is doing, and I saw that the DNV, which is a certification society, they have a very detailed list on what kind of steel you are using when you are building a ship, into what parts. And if you have U-frame or I-frame or T-frame, you use different steels and so on, very detailed. And when I looked into what IMO, or International Maritime Organization, is saying on security, and I found a paper that says that security is important, we should have maritime security, cybersecurity. So I think that, I don't know if we have moved forward this year, but I think that here we have a quite big empty area. At least as an outsider, it looks to me like that. And that's like, I don't know how far we are along this, but how to design a ship in a secure way, cyber secure way. And we have a Purdue model. A Purdue model is same as we used on internet in the 90s, but you have separate segments. You have a office segment, and then you have actual process segment, and then you have firewalls. And on the internet side, firewalls are not preventers, they are slowers. Firewalls are speed bumps. If you want to break into a system, you see a firewall, it will slow you down, it will not prevent you. If you are a serious attacker with serious resources. Governments and organized crime. And organized crime now has real money, and organized crime is organized. It's not like it's a bunch of goons. It's very hierarchical, horizontal structure with specialists who specialize on different parts of a crime. And same intelligence agencies, governments. And compared to military, cyber is very, very cheap. Like the Stuxnet about 10-15 years ago, attack on the Iranian nuclear refinement, budget maybe 10 million US dollars. On a military, 10 million US dollars is nothing. Cruise missiles already cost $1 million, but bang. So you fire one cruise missile, you need a whole infrastructure. It's easily $10 million to fire one missile. With a cyber, with a Stuxnet software, they could break the process without Iranians even realizing that they are being attacked. Initially, they just thought that, oh, our centrifuges are breaking. Must be a material problem. Very clever. Yeah. Now on shipboard, same things. How do you plan your security from beginning? How do you separate the systems? How do you make sure systems are separated and stay separated? When you have a ship where people during a building phase are walking in and out, you have hundreds of people walking all over a ship from different companies, different suppliers. And after a ship is built, who owns it, who runs it, who everybody is involved in a ship. What I understand is that quite often you have 10 different companies operating on a ship doing different things, especially cruise ships. Yep. And how do you monitor this? And I don't know this is state of the art, but I kind of assume, based on my previous experience, that there's lots of room to figure out things here. And like, how do you make sure that nobody attaches anything to your OT side of a system, the controls of a ship? If somebody attacks the entertainment system, that's no big deal. And modeling the attacks, like thinking that, okay, now who is going to be trying to break the security on a ship and how and why? And this issue, like, what happens when you are at sea? You will have a Starlink, you will have internet connectivity. We know that. If you don't have it yet, you will have it. You have a whole entertainment system, you have people, you have your crew watching videos, sending emails, whatnot. So the ship is not isolated as itself from the internet. And now if somebody puts in enough effort, they get in through a Starlink, and if your systems are connected, they can get forward. You have your navigation system, you update your maps, you do route planning on a desktop or laptop someplace that is connected to your navigation system. It's all connected unless you make sure it is not connected. And when I send in the malware and when I shut down Starlink. Now you have a ship without digital communications, you still have radios. What do you do? Has anybody thought about this? And what skills do you have on board? I would assume in practice you don't have cyber skills. We can't train so many people very deeply into cyber and then put them on ships doing something else. And emergencies you practice for. So how do you practice for cyber attack on a ship? Like what prevention you can do, what procedures you have if something goes wrong, like how do you recognize you are under attack? What is the first problem? And when you recognize it, what do you do? And then how do you practice this? Like what kind of cyber practices you should have on board for ships so that when something happens, people are prepared and know what to do. I think that this will be interesting research question. I have no idea how to do this, of course, but that's no problem. We do science by asking questions, not by starting with answers. And when kind of a life cycle of a ship, like how do you actually start from the beginning? And you have to remember that somebody's building, somebody's buying, somebody's operating, different parties. And right now we don't even know how to request security. If I'm buying something, unless I'm buying a specific small digital device where I can refer to the US FIPS regulations. United States government has the Federal Information Processing Regulations for certain devices, but none exists for ship. So how can I even request a cyber secure ship? We don't know yet, but I can say that okay, I want a ship that goes in big waves, and DNV will certify it, so build it according to DNV rules, and we will do it. So it should be that at some point we can define what is a cybersecure ship, and you can just say that, okay, here are the rules, follow them, and those rules will actually produce good results. It is a different thing from making the rules. It will take time and research. Okay, so in conclusion, the state of software security right now it's very variable. You have islands of good and lots of bad, and lots of legacy, tons of legacy. It's like if you talk to the coders, they say that, oh, we'll rewrite this in 4 years. And if you go to the field, you see still stuff from the 90s being running and being connected to the internet. And of course, the security has to be built in from the beginning, and you start with security analysis. You don't end with security analysis. And our EU regulation will demand this. And then my assumption that there is lots to do on the maritime sector, but like I said several times, I'm no specialist on this. All right, thank you very much. Now please ask questions.
Thank you very much, Dr. Kiravuo. It was a very inspirating talk and opened up our eyes in terms of challenges in business industry, including maritime, when it comes to cybersecurity. Even though we have huge recommendations, I will say, rather than regulations. So yeah, as the researchers, we have very challenging task. But if I may just share with you my opinion that we should start with IT and OT developers, because they are the persons who might get us insights of vulnerabilities of that equipment in terms of cyber attack. So we should start from the very beginning, from the development of IT, OT equipment and software which runs it. So maybe we should not start from the end, but from the beginning of the problem, let's say. So it's just a small comment, and of course I'm calling the audience for questions, comments, suggestions.
Please somebody tell me I'm wrong.
No, you are not, I'm afraid. In maritime cybersecurity, we are trying to do our best, but at least our group came up to the conclusion that still maritime industry is very vulnerable, especially when it comes to ships. And colleagues are working to change that current state. But still it is in infant stage, I would say. Yes, Ivers, please go ahead. You are muted, sorry.
Hello, thank you very much for this great presentation. I have a question based on your experience, maybe. What do you think of the qualified number of experts in the maritime industry? Does the maritime industry have sufficient number of experts on maritime cybersecurity? What's your idea? If you share your opinion, it would be much appreciated. Thank you very much.
Yeah, like I said, I have not been working with maritime industry. I have had occasional touches, but I haven't seen a maritime security expert yet, which might answer a question. But so my guess is that what I see happening is that we have different fields of industries, and every industry is doing what they are doing until they have a big cyber incident and when they wake up. Same as hospitals. In England, they had ransomware in some hospitals who had to shut down, and all of a sudden the medical side got interested in security. On maritime, we had a Maersk incident, and all of a sudden everybody in the maritime industry started to talk about security. And when it takes some time, that actually happens something. But so that is just my guess. Unless somebody knows that there's a huge amount of maritime security experts hiding someplace. Maybe they have to see.
Thank you very much for your reply.
Please feel free to ask me anything. Since I'm a generalist, I'm a specialist on everything.
If I can ask one question, you mentioned apps and reverse engineering. What did you mean by that? That each and every installed app can be reversely re-engineered, and how it can be reflected on cybersecurity issues?
Yeah, it means that I lost my cell phone somewhere. So you have a cell phone, you make an app for cell phone, plop. It means that now it is on my cell phone. And of course, I can jailbreak my cell phone. I take a binary code, and actually not me, I suck at coding, but somebody who knows how to do is they just reverse engineer it. So anything that goes out of your network to the internet can be reverse engineered, interpreted, interrogated. It's like I can see the logic behind. I can then write a different app or modify the app in such a way that it says that okay, this customer has paid, this customer has accepted something, and let's say that you are designing a control app for something, and you put the limitations for control, like you can't run the motor too fast. You put version of app. I change the app, and then I can run the motor too fast. Or if I'm bus passes, if I go to a bus, I show my bus pass on an app. I can easily make a different app that looks the same. But when if you do some kind of verification, I can try to figure out what can I also fake the verification, so that even if the inspectors come, my app will say that I'm okay. And that means that any software you put on board a ship, somebody will get their hands on and examine that software. Any security you have for updating your engine control systems, somebody can go through them and see what can they break the security. There are no secrets. Anything that leaves your house is no longer secret. And that is something that lots of people are realizing, but not everybody. And I have still seen in the past years developers trying to put the authentication verification onto the app side or onto the JavaScript side, which just makes zero sense. You need to have a right amount of distrust and understand that you are always under attack. Yeah.
Yeah, thank you, but it seems impossible to avoid all these threats. And also, I heard recently about the cybersecurity quantum layer that is going to be applied. How and where, I don't know exactly, and I didn't figure out. So I'm asking you, are you aware about that possibility of putting some kind of quantum computing cybersecurity layer into the networks or something like that? I just heard about it, but I didn't dig deeper into that direction.
Yeah, basically, I have been looking at the quantum computing as breaking encryption, which might happen. We have quantum encryption also, but right now quantum encryption is mostly a research topic and it's very expensive. And we have this like right now what we have is that you can fire a photon over a fiber optic cable, and when you have a encrypted data on a polarization of a photon, and when you read it, and it's very slow and very expensive. So I don't think that quantum is helping anything in the near future, at least, or like a new threat.
And if I understood you well, it works only with fiber optic cables, not with Wi-Fi.
Yeah, the current, well, yeah, there is some quantum entanglement encryption being researched, but I haven't followed that one recently. So, but at the moment, anything related to quantum is expensive, and it's in the future. But I don't know what we'll see. But it's still so far in the future that it's like beyond my horizon. I think that right now the focus should be maybe the industry focus, not research focus. Research focus should be in the future, but the industry focus should be kind of in what we have right now and can implement in future years. But when in the research, of course, we should look more forward and try to invent those things that don't exist yet.
Okay. Nona, please proceed with the question or comment.
Yeah, thank you. I think it was a very good presentation because you touched the very large amount of security risk points. And I think you stated it, that most of these risks are usually related to bad processes in developing software or in assessing the risks, not so much on the technology itself. I mean, at the end, you can have the most secure technology, quantum encryption or whatever, but you will still depend on the people and the processes that these people will be handling. Saying that, there is a lot of things that could be improved, and I appreciated your presentation on getting them forward, because like in other areas where security is paramount, being elevators, being cars, etc., these issues need to be raised and atoned for in software development. And I think you also mentioned this, but the recent AI-based development lacks a lot of this security training that people were having. And right now it's missing in a lot of solutions that are mostly focused on rapid deployment, but not on a secure deployment. So yeah, thank you.
Yes, but yeah, actually, we have something called vibe coding, where you give AI prompts, and when you get a software product, and unfortunately, people are actually deploying those. Yes, it's like yeah. The problem with generative AI is that the current version, it's like what we are now. It will give you always an answer, and it will give you an answer that it thinks looks right, but it doesn't understand the content. So from AI, what you get is questionable, and when unless your AI has had enough training materials on security and so on, and unless you're requesting it, you get no security. And when people will test that, okay, I asked it to do this, it does this, okay, it's fine. It does what I ask it to do, I can deploy it. And not think at all that what else it might be able to do and what else somebody else might be able to make it to do. So yes, AI is gonna be a huge vulnerability for everybody in the world.
Yep.
We will figure it out at some point, but it will take some years.
Mhm.
We have survived. We survived motor cars and we survived rock and roll, so maybe we survive AI too.
Yeah, we survived a lot of innovations during the history, so hopefully we will survive AI and quantum computing and all that. This is in fact beyond our understanding. But yeah, let's hope for the good outcome at the end of the story. Do we have more questions, comments from the audience? If not, I would like to thank you all for your time, for joining this meeting, and in particular, I would like to thank Dr. Kiravuo for sharing his rich experience in industry with us. And yeah, that will be all for today's research seminar. Thank you very much for joining us. Thank you.